What happens to your body on every planet? Let's talk about something wild. What would actually happen to your human body if you stepped foot on each planet in our solar system? Not just whether you'd survive, but the specific ways your body would react, change, and ultimately fail on these alien worlds. We're going from the innermost planet all the way to the edge of our solar system, and trust me, it gets pretty intense. Mercury. Picture this. You're standing on Mercury, the sun's closest neighbor. The first thing your body would experience is the most extreme temperature whiplash imaginable. If you landed on the day side, the ground beneath your feet is literally hot enough to melt lead at 430 degrees Celsius. Your body's natural cooling system, sweating, would be completely useless. The moisture would evaporate from your skin instantly. Within seconds, your blood would start to boil through your vessels. Your proteins would denature, meaning the building blocks of your cells would literally cook and fall apart. But here's what makes Mercury truly bizarre for your body. Because there's virtually no atmosphere, there's nothing to distribute heat evenly. One side of your body facing the sun would be cooking, while the other side could be freezing. Your body's homeostasis, that careful balance it maintains, would be completely overwhelmed trying to manage these opposing extremes simultaneously. Now, if you somehow landed on the night side, you'd face the opposite problem. At minus 180 degrees Celsius, the water in your cells would begin to freeze and expand. This expansion would rupture cell membranes throughout your body. Your extremities, fingers, toes, nose, and ears would experience frostbite within seconds as blood flow constricts to protect your core organs. But even that wouldn't save you. Your core temperature would drop, triggering severe hypothermia. Your heart rate would slow dramatically. Your brain function would deteriorate, and you'd lose consciousness within minutes. The lack of atmosphere creates another problem. Without air pressure, the liquids in your body would begin to vaporize. Your saliva would boil off your tongue. The moisture in your lungs would turn to vapor. You'd experience something called ebullism, where the fluids in your soft tissues form gas bubbles. Your body would swell as these bubbles formed under your skin. Venus. Moving to Venus, Earth's so-called sister planet. But let me tell you, Venus treats the human body like nothing else in our solar system. The atmospheric pressure here is 92 times that of Earth. To put that in perspective, it's like being 900 meters deep in the ocean. Your body would be compressed from all sides simultaneously. Your rib cage would be pushed inward, making it nearly impossible to expand your lungs. Even if you tried to breathe, you'd be inhaling almost pure carbon dioxide mixed with clouds of sulfuric acid. That acid would immediately begin dissolving the mucous membranes in your nose and throat. Your lungs would fill with fluid as the tissue breaks down, essentially drowning you in your own bodily fluids. But it gets worse. The temperature is a consistent 450 degrees Celsius across the entire planet, day or night. At this temperature, your skin would begin to char within seconds. The subcutaneous fat layer beneath your skin would literally start to render like cooking fat. Your blood vessels would rupture from the heat, causing massive internal hemorrhaging. The proteins in your muscles would denature and seize up. Your brain, being extremely sensitive to heat, would experience rapid cell death. You'd likely lose consciousness within 10 to 15 seconds as your neurons failed en masse. The sulfuric acid in the atmosphere wouldn't just affect your lungs. Any exposed skin would experience chemical burns that would penetrate through multiple layers. Your eyes would be particularly vulnerable. The corneas would cloud and burn away almost instantly, causing permanent blindness before anything else could kill you. Mars. Now Mars is interesting because it's the only planet where your body might last more than a few seconds. Relatively speaking, the temperature can actually be tolerable during the day in equatorial regions, around 20 degrees Celsius. Your body could theoretically handle that. But the problems start stacking up quickly. First, the atmospheric pressure on Mars is less than 1% of Earth's. This is below the Armstrong limit, the point where water boils at body temperature. What does this mean for you? The saliva on your tongue would begin to boil. The moisture in your eyes would vaporize. You'd feel your soft tissues swelling as the water in them tries to turn to gas. Your lungs would be unable to absorb oxygen even if you tried to breathe the thin Martian air. because there's not enough pressure to push gases into your bloodstream. Within 15 seconds, you'd lose consciousness from lack of oxygen to the brain. This is called hypoxia. Your heart would continue beating for another minute or so, desperately trying to circulate oxygenated blood that isn't there. Your brain cells would start dying after about 4 minutes without oxygen. Permanent brain damage would set in, though you wouldn't be conscious to experience it. The cold would be your next enemy. At night, temperatures plummet to -73 degrees Celsius. Your body would lose heat rapidly in the thin atmosphere. Frostbite would set in on your extremities. Your core temperature would drop. And if you somehow survived the pressure and oxygen issues, hypothermia would eventually shut down your organs one by one. The radiation exposure on Mars is another silent killer. Without a magnetic field or thick atmosphere, cosmic rays and solar radiation bombard the surface constantly. Your cell's DNA would accumulate damage at an accelerated rate. If you somehow survived everything else, this radiation would increase your cancer risk dramatically and cause acute radiation sickness with symptoms including nausea, vomiting, and hemorrhaging. Jupiter. Jupiter is where things get really extreme. You'd never actually land on Jupiter because it's a gas giant with no solid surface. But let's talk about what would happen to your body as you fell through it. First, before you even entered the atmosphere, the radiation would begin destroying your cells. Jupiter's magnetic field traps charged particles, creating radiation belts far more intense than Earth's Van Allen belts. These high-energy particles would penetrate your body, breaking apart DNA strands and killing cells outright. You'd develop acute radiation syndrome. Your bone marrow would fail, meaning you'd stop producing blood cells. Your intestinal lining would break down. You'd experience severe nausea and vomiting within hours. As you entered the upper atmosphere, you'd be falling at incredible speeds due to Jupiter's gravity being 2.4 times Earth's. The G-forces alone would be problematic. Your blood would pool in your lower extremities. Your heart would struggle to pump blood up to your brain against the intense gravity. You'd experience tunnel vision, then gray out, then complete blackout as blood flow to your brain decreased. The temperature in the upper clouds is around -150 degrees Celsius. Your body would begin to freeze, but you'd be falling so fast through layers of increasing density that you'd also experience massive friction heating. Your body would simultaneously freeze and burn in different areas, experiencing forces that would literally tear you apart at the molecular level. As you fell deeper, the pressure would increase exponentially. Your body, cavities, lungs, sinuses, and even the space in your joints would be compressed. Your bones would crack under the pressure. Eventually, the pressure would become so intense that your body would be compressed into a much smaller volume. Every cell would be crushed, and you'd essentially become part of Jupiter's dense inner layers. Saturn. Saturn presents similar challenges to Jupiter, but with its own unique twists. The atmospheric composition is comparable, mostly hydrogen and helium, which your body can't process. You'd suffocate from lack of oxygen even as you breathed, a disturbing sensation where you're inhaling and exhaling but getting no benefit. The winds on Saturn are even more extreme than Jupiter, reaching 1,800 kilometers per hour near the equator. At these speeds, the wind itself would become a weapon against your body. Small particles in the atmosphere would sandblast your skin away. The sheer force of the wind would ragdoll your body, breaking bones and causing massive trauma. Your neck would snap, your limbs would be torn from their sockets, and your internal organs would be pulverized by the violent turbulence. If you entered near Saturn's North Pole, you'd encounter that massive hexagonal storm. The turbulence here would be even worse. Your body would be thrown around with such force that your brain would impact the inside of your skull repeatedly, causing severe traumatic brain injury. Your blood vessels in the brain would rupture, causing hemorrhagic stroke. As you descended deeper into Saturn, the increasing pressure would compress your body more and more. Your lungs would collapse completely. Your eyeballs would be pushed back into your skull. The air spaces in your body would fill with the surrounding gases compressed to liquid form. Eventually, at the core, you'd encounter temperatures around 11,700 degrees Celsius. At this point, your body wouldn't just burn, it would vaporize. Every molecule that once made up your body would be broken apart into its constituent atoms. Uranus, the sideways ice giant, presents a unique set of challenges. The first thing your body would notice is the cold. At -224 degrees Celsius in the upper atmosphere, this is colder than anything we've discussed so far. The extreme cold would cause your blood to thicken and flow sluggishly. Your heart would have to work much harder to pump this thickened blood. Ice crystals would form in your blood vessels, causing blockages. Your brain would be one of the first organs to fail from lack of adequate blood flow. Your body's extremities would freeze solid almost instantly. But unlike regular frostbite, the cold here is so extreme that the water in your cells doesn't just freeze. It freezes so rapidly that it forms sharp ice crystals that pierce through cell membranes from the inside out. Your tissues would become brittle, and any movement would cause them to shatter like glass. The composition of Uranus's atmosphere includes methane, ammonia, and hydrogen sulfide. If you tried to breathe, these toxic gases would cause immediate chemical burns in your respiratory tract. Hydrogen sulfide is particularly nasty. It interferes with cellular respiration, meaning even if you had oxygen, your cells couldn't use it. You'd experience cellular hypoxia, where your cells suffocate, even with your blood still carrying oxygen. As you fell deeper, you'd encounter layers where the pressure converts these gases into icy slushes and eventually into exotic states of matter. Your body would be crushed, but the extreme cold would also make your tissues so brittle that you'd essentially shatter into fragments before being compressed further. The diamond rain that occurs in Uranus's deeper layers is fascinating but deadly. The extreme pressure that creates these diamonds would be applied to your body as well. Your carbon-based body would be subjected to the same forces. The carbon in your body might theoretically begin to crystallize, but you'd be long dead before this process could occur in any meaningful way. Finally, Neptune, the most distant planet. In many ways, it's similar to Uranus, but with even more extreme conditions. Neptune's winds are the fastest in the solar system, reaching supersonic speeds of up to 2,100 kilometers per hour. Your body would be subjected to forces beyond anything it was designed to handle. At these wind speeds, the friction alone would heat your body's surface even as the ambient temperature is incredibly cold. Your skin would ablate away, stripped off by the sheer force of the wind and particles it carries. The turbulence would cause your body to tumble and spin at rates that would tear ligaments and break bones. Your inner ear, which controls balance, would be so overstimulated that you'd experience severe vertigo, though you'd barely notice given everything else happening. Neptune's core temperature reaches about 7,000 degrees Celsius, hotter than the sun's surface. As you descended through the layers, your body would experience an incredible temperature gradient. The transition from the frigid outer layers to the scorching inner regions would cause your body to undergo thermal shock. Different parts of your body would be at wildly different temperatures, causing your tissues to expand and contract at different rates. This would literally tear your body apart from the inside. The pressure near Neptune's core is immense, thousands of times Earth's atmospheric pressure. Under these conditions, your body would be compressed to a fraction of its normal volume. The spaces between atoms in your body would decrease. You'd essentially become a denser version of yourself before the atomic bonds themselves began to break down under the extreme conditions. Conclusion. So, there you have it. 8 planets, 8 different ways your body would fail, break down, and ultimately cease to function. From the temperature extremes of Mercury to the crushing depths of the gas giants, from the acid clouds of Venus to the diamond rain of the ice giants, every planet in our solar system is hostile to human life in its own unique way. The human body is an incredible machine, evolved over millions of years to survive on Earth. But take it anywhere else in our solar system, and it becomes painfully clear just how specialized we are for our little blue marble. Our bodies need very specific conditions. The right temperature, the right pressure, the right atmosphere, the right gravity. Change any one of these factors drastically, and our bodies fail in spectacular and often disturbing ways. Makes you appreciate Earth a little more, doesn't it? This thin layer of atmosphere, this perfect distance from the sun, this just right gravity. These are the only conditions in our entire solar system where your body can exist as it is. Pretty amazing when you think about it. If you enjoyed this journey through the solar system and want to see more videos exploring space, science, and the universe, make sure to subscribe. And let me know in the comments which planet's effects on the human body surprised you the most. Thanks for watching, and I'll see you in the next video.